Alright, hello Year 9. The last time I did a lesson, we were looking at finding the missing sides using some trigonometry that you did for the first time. I was really pleased at the work that you did for me on Hegarty Maths. It showed lots of really great understanding. So well done. Now, so in our last lesson, we were looking at, for example, the cos of an angle like cos of 46 degrees. And as you know, we can type that into our calculator. And if you're right, you'll get 0.69 to 2 decimal places. Could you just type in sine of 20 degrees for me, please? And could you type in this tan of 123 degrees for me? If you get the same answers as me, it means that your calculator is in degrees mode. So the sine of 20 degrees is 0.34, again to 2 decimal places, and the tan of 123 degrees should be negative 1.54 to 2 decimal places. Okay, so it's perfectly possible to have an answer that's a negative value. What we're doing today, however, is, for example, if I was to give you the cos of an angle is 0.5, how would you find angle X? So what I'd like you to do is, can you think of a way on your calculator where you could figure out what the angle was that when I type in cos of that value, I end up with 0.5. You can press pause while you have a little think about it. Okay, right, so let's get a nice light coloured pen. I'll get my nice pale blue. If you have a look above the cos button, you will see in yellow there is a cos with a negative 1. That is the inverse function of cos of an angle. You can do that by pressing Shift and cos. Now, because we're working backwards and we know this 0.5 value, to find x, what we need to do is we need to do the opposite of cos, which is Shift cos, or cos to the negative 1 of 0.5. Why don't you type that into your calculator? Start by typing Shift cos of 0.5, close that bracket, and you should get an answer. And you should have x is 60 degrees. So that's how to work backwards. So that's what we're doing. We're working backwards. We're finding the inverse. You can do it with sine and tan as well. So let's just go down a little bit. And for example, if I told you that the sine of a different angle was something like 0.3, do you remember what you would do to find y working backwards? Well, if you look above the sine button, you've also got a sine with a negative 1. So if you type in Shift and sine, it should say sine with a negative 1 on your calculator, and then type in the 0.3, and you should get an answer for y. It might be a very long decimal. In fact, I've done that on purpose. You should get 17.4576, etc. Now, that has to be in degrees because you can only take the sine of an angle. So y is equal to, and let's put it to 1 decimal place, 17.5 degrees to 1 decimal place. I'm going to give you 2 more that I'd like you to have a go at. I've got the tan of angle Z degrees is going to be 4, and I'm going to write down the cos of a different angle, let's call it M, anything I like, is 0.86. Okay, so could you have a go at those for me, please? You can press pause. Okay, so to find Z, I've got tan with a negative 1, so Shift tan of 4. And I'm going to type that into my calculator just like you, Shift tan of 4, and I end up getting 75.9637, etc. So I'm going to put it to 1 decimal place, which is actually going to be 76.0 degrees to 1 decimal place. Notice how all my answers now are angles. And very similarly for the one on the end, M is Shift cos, or the inverse of cos with a negative 1 of 0.86. And if I do that on my calculator as well, I end up getting 30.7 degrees, but I've actually rounded that to 1 decimal place. So I'm not going to write down all my decimals there because I've got my final answer. If I was going to use that exact angle in a calculation, I wouldn't round up until right at the end of the question. Okay, so that's what we're going to be working on today. We're going to be working on finding angles, finding missing angles in a triangle. Now, last lesson, I taught you how to find a side. So can you just recap what you learnt from last lesson and see if you can find side X in this triangle? Press pause. Okay, remember, opposite the angle, we've always got the opposite side. Next to the angle, we've always got the adjacent side. And I could label the hypotenuse as always the longest side opposite the right angle. Now, I needed to put the right angle in that triangle. I forgot to do that. Otherwise, this wouldn't work if this wasn't a right angle triangle. Now, we've only got two sides that are either given or required. We've got the opposite and the adjacent. And last lesson, I taught you about so, ka, or toa, and toa. And we learnt last lesson that the sine of an angle is the opposite of the hypotenuse. We learnt that the cos of an angle, the cosine of an angle, is the adjacent over the hypotenuse. And we also learnt that the tan of an angle is the opposite over the adjacent side. Now, if I look at this triangle, I've only got the opposite and the adjacent sides that I'm remotely bothered about. So it's going to be the one with toa. It's going to involve the opposite and the adjacent. And it's the only one of our formulae that involves both of those letters. So I know that the tan of my angle is the opposite over the adjacent, so it's 4 divided by x. I'm going to multiply both sides by x to get x multiplied by tan 30 degrees is 4, and therefore x is 4 divided by tan 30. So I'm just going to quickly type that into my calculator, 4 over tan 30, and I end up getting 4 root 3. Oh, I like that answer a lot. 4 root 3. It's probably in centimetres, but it could be in any other units, so I have no idea really. I shouldn't really write centimetres. I should write units because it's the length of the side, and I don't know the units. But if I wanted to have an answer to a decimal place, that would be 6.9 units to 1 decimal place. I quite like the answer 4 root 3 because it's an exact answer, and I could use that in another calculation nicely if I had to. So that's what we did last time. But today I want to discuss what we do if the angle is unknown. You've already got that skill that you're going to need. Now, I must put in a right angle, otherwise this question would not work. We've been given two sides of this triangle. We've been given the hypotenuse, and we've been given the opposite side. If you wanted to label the adjacent as well, that's okay, but it can get a bit confusing until you highlight, just write down the labels of the sides that you've actually got. So if I think about those three little words, so, ka, and toa, the only one that involves the opposite of the hypotenuse is so. So remember, that means sine of the angle is the opposite divided by the hypotenuse. So I know that the sine of my angle is 3 divided by 5. Now my calculator works with fractions really nicely, but it's obvious that I need to find this angle. Now because I'm finding an angle, we've always got to use the inverse trig button. So I'm going to up to the side. Finding an angle always involves an inverse trig function. So that's for your notes. And if I was going to highlight anything, finding an angle always involves an inverse trig function. Now, what's the inverse of sine x? Well, if I'm solving an equation, I've got to do the same thing to both sides. So the sine of an x, and then doing the inverse of sine gets me back to the angle. And I'm going to do the inverse sign of my fraction 3/5. I can use my fraction button to enter that. So I'm going to enter it as well on my calculator, shift sign, 3/5, or 3 divided by 5 if you like, actually gives me 36.869, etc, etc, etc degrees. I could just write down x is equal to 36.9. So 1 decimal place. And that's usually enough decimal places for these questions. Please check Hegarty to see what accuracy you've got to give yours to. Okay, so why don't you have a go at these 3 now? I'm going to go over all 3. Have a go, please. Press pause. Right, I'm going to go over each one individually for you. So I've got the hypotenuse and I've got the adjacent, and I know that I've got to use the car formula. So the cos of x is the adjacent over the hypotenuse. Always start by writing that down. That means I'm going to get my letters in the right order and my numbers in the right order. Is 7/12. And finding x, I've got to do the inverse cos of 7/12. I type that into my calculator and I end up getting 54.3 degrees to 1 decimal place. I hope you got that one right. Let's have a go at the next one. So I've got the hypotenuse and I've got the opposite, which means that the word SO is involved. And I'm just going to write down what that means. Sine of x is the opposite over the hypotenuse. So the sine of my angle is 8/14. And if I'm finding my angle, I've always got to do the inverse. So it's sine, shift sign I should say, 8/14. Type that into my calculator. I get 34.8499, etc. So I'm going to write down 34.8 degrees to 1 decimal place. Part C. So this time I've been given the opposite and the adjacent. And I think TOA is involved here, so I know the tan of my angle is the opposite over the adjacent. And therefore the tan of x is 5/10. To find an angle, I'm always doing the inverse. So I've got the inverse of tan, 5/10. So I'm going to do shift tan of 5/10. And I get 26.6 degrees. Notice how all of my answers involved an acute angle. Remember, in a right angled triangle, I can only have 2 other angles that are acute. So if you had an obtuse angle as your answer, I think you'd have done something wrong. If you had a reflex angle in your answer, it wouldn't be correct for the actual triangle. Right, you ready for some stretch and challenge? There seems to be a reindeer on this picture, and I really don't know why. So I've got this situation here. You can probably see 3 triangles like me. And I've got 2 angles that I can see and 2 lengths. And the idea is you've got to find length x. There's one other thing I should tell you. There is a right angle in the corner on the bottom right. Please have a go yourself, and then I'm going to go through this step by step. Okay. So the first thing I really need to do, if I'm looking at this question, is I really need to notice that I've got 2 triangles inside a larger one. But it's only the right angled triangles that are going to be of any use initially. I've got one right angled triangle with an angle of 60 degrees and a 3 metre base. And then I've got a larger right angled triangle that's got a right angle, an angle of 40 degrees, and a length of the base of x add 3. I can't find length x, but what I do know is that if I were to find the height for both of those triangles, it would have to be the same. And once I've got the height for the second triangle below, I could work out the length of that horizontal. So I'm going to call that height y. I'm going to put it on the large diagram so that you can see both triangles would share that same height. Now y happens to be opposite to 60 degrees and the 3 meters happens to be adjacent to 60 degrees. So I'm going to think about TOA. So I know that the tan of my angle is the opposite divided by the adjacent. So if I do 3 multiplied by tan 60 degrees, I get length y. So I'm going to type that into my calculator to see if it's a nice number. Well, I get 3 root 3. That's okay. So y is equal to 3 root 3 meters. So I'm going to write that in on my big diagram. And I'm going to now write that in my bottom diagram because now that's a piece of information that I know. So my bottom diagram, the big question is, what is the length of that base? And I'm going to go to a different colour pen now because I'm enjoying my colour selections. Now I can see my base is the adjacent side to the 40 degree angle. And I've got the 3 root 3, which is the opposite side. So I'm thinking about TOA again. So I'm thinking that the tan of my angle 40 degrees is the opposite side, 3 root 3, divided by my adjacent side. X, add 3. Okay, so I'm going to scroll down a little bit there. Doesn't look very nice at all. So what I'm going to do, I'm going to multiply both sides by my x, add 3. Lots of tan 40 degrees is equal to 3 root 3. Now I can divide both sides by tan 40, and that would leave me with x add 3. So 3 root 3's divided by tan 40 is going to give me the answer to x add 3. I'm going to do that on my calculator. I've got 3 times root 3 over tan 40. Notice I'm not rounding any values. I'm keeping those exact values in. So I've got x add 3 is equal to 6.192533, etc. Well, I need to find x. If I take away 3 from both sides, I believe that I've found it. So I'm just going to take away 3 from my last answer, and I get 3.19, and that is meters to 2 decimal places. If you've done it to 1 decimal place, that's fine as well. That would be 3.2, of course. So I hope that was okay for you. You might not have done it exactly the same as me with that algebra. You might have just found the adjacent side and then subtracted 3 from it, and that's exactly what I did really. There are 2 Hegarty tasks set on this exact skill, so very best of luck and do contact me if you need help with anything. Bye for now.